So the important part, what we are starting is the remaining test, remaining statistical test, right? So we have seen the chi-square test till now. In a simple manner, what we have to do in any of the test is to know, we should know the formula. We should formulate the null hypothesis and alternate hypothesis, get the values of the formula, and then calculate the test statistics. Now look into the standard values by considering the significance level, right? You have to calculate the degree of freedom, consider the significance level, look into the standard values of the tables of those tests, and then find out the value for from the table as well, and compare your test statistical test with the tabular values and um, get your hypothesis either rejected, null hypothesis either rejected or accepted. These are the simple tests to be performed, simple steps to be performed in any of the statistical tests. So now we will look into the t test. Now what is the t test? We have to look, see this test we are looking currently. So this test is the statistical test used to compare the means of the sample. Note it down. What does it do? It compares the, just a second, I will take the pen. Okay. So what does it do? It compares the means of the sample, correct, or the two groups, to determine if there is a significant difference between them. In a very simple, in a very layman's language, I would say that it compares the two samples. Mean value म्हणजे काय असते? Average value जी आपली आहे sample ची, correct? So the mean of one sample and the mean of another sample will be compared, and it will say that whether there is a significance difference between the two samples. Ekdam simple example. Say I have the assembly line, correct? And this assembly line produces the say nut bolts. The assembly line produces the nut bolts for a complete day. What I will be doing, say I found that in the night, due to the ignorance of the workers, I'm not getting the good quality nut bolts in the night, correct? So in this simple, see, this is just my observation. It can be the observation, may be wrong also. So what I'm supposed to do is, I am supposed to calculate, I am supposed to have the means of the nut bolts which are getting produced in the night, means of the nut bolts which are going to get produced in the daytime. I will compare these two means, and whatever value I get is, I will be saying that whether these two samples are having the significant difference or no difference over there, correct? So this is commonly used when the sample size is small or the population standard deviation is unknown. So there are three types: the one sample t-test, independent two sample t-test, pair sample t-test, which is called as the dependent. So please remember, there are three types of the t-test: the one sample t-test, independent two sample t-test, and the pair sample t-test, that is my dependent t-test. And when I do this t-test, when my sample size is very small or the population standard deviation is unknown, in these two cases, I will be doing the t-test, correct? Now we'll be looking into the formula for the t-test. The formula for the t-test is T is equal to, over here you can see the formula for the t-test. What is the formula for the t-test says? The T is equal to x bar minus mu 0 divided by S divided by under root of n. So let me explain you each term. So x bar is my sample mean, mu 0 is a population mean, sample standard deviation is my S, and the n is my sample size, correct? So say take an example. Suppose we want to test if the average height of the sample of the 30 student is significantly different from the national average height of the 160 centimeter. कळलं? काय करतोय आपण? सॅम्पल 30 स्टुडंटचे सॅम्पल आहे, त्यांची ॲव्हरेज हाईट ही नॅशनल ॲव्हरेज हाईट किती नॅशनल, वी हॅव मेड दी सर्वे इन दी नेशन अँड इट सो आय सेड दॅट द नॅशनल ॲव्हरेज हाईट ऑफ दी स्टुडंट्स इज दी 160 सेंटीमीटर. तर ही जी नॅशनल हाईट आहे ती मला कम्पेअर करायची आहे सॅम्पल ऑफ 30 स्टुडंट्स बरोबर. So what is my null hypothesis? The means equals the population mean, correct? The sample mean equals the population mean is my null hypothesis. And what is going to be my alternate hypothesis? The sample mean is not equal to the population mean is my and alternate hypothesis. Correct? So I hope this is clear with all of you about the one sample t-test. Let's move ahead and see the next part. So there are two sample t-test also. So here I am supposed to compare the mean of two independent groups. Correct? Please remember the role of this two sample t-test is different. What does this two sample t-test do? It compares the mean of two independent group to see if they are significantly different from each other. The simple example of this is comparing the average test scores of the two groups of the students from the different schools. Correct? So two groups have the same mean and the two groups have the different mean. एकदम simple formula आहे ह्याचा, आता तो आपल्याला इथे दिसत आहे. Correct? Then the next is the paired sample t-test. So they have the different sample formula for the paired sample t-test. So to compare the means of the two related groups, such as the same group tested at the different types. Two different types, correct? So measuring the blood pressure of the patient before and after taking the medicine. That's a simple example. Sample t-test, dependent t-test. So example काय आहे की blood pressure of the patient which we are verifying the before and after taking the medicine. Right? Now moving to the steps to perform the t-test. As I said we are supposed to state the hypothesis, calculate the t-test, check the degree of freedom, find the critical value at the given alpha level and the confidence level, and make the decision. Fine. So that's how my test work. Example of one sample t-test. I want you all to write down the example. I will just dictate. A company claims that the average age of its employees is 30 years. What is the company's claim? That average age of the employees is 30 years. A sample of 25 employees has an average age of 28 years. करेक्ट. आता सॅम्पल घेतला 25 एम्प्लॉईजचा आणि त्याचा ॲव्हरेज 28 इयर्स आलेला आहे. So with the standard deviation of 4 years, test this claim at the 5% significance level. I hope you have understood the numerical. So the problem statement is the company claims that the average age of its employee is 30 years. Company claims that average age of employee is 30 years. म्हणजे ॲव्हरेज एज दिलेला आहे, सॅम्पलचा एज दिलेला आहे. स्टँडर्ड डेव्हिएशन 4 इयर्सचं दिलेलं आहे आणि आपल्याला टेस्ट क्लेम करते 5% ऑफ सिग्निफिकन्स. दिस इज व्हॉट इज गिवन, राईट? सो वी विल मूव्ह अहेड अँड सी. So over here you have the null hypothesis that mu is equal to 30. Alternate hypothesis mu is not equal to 30. Correct? Mu, what is the mu? Mu is the population mean. X bar is the sample mean, mu is the population mean. A simple, we will fill the values in the formula at the, we will find out the degree of freedom as 24. Alpha, because we said that the 5% of significance level, so alpha is 0.05, correct? 5% of significance level, so alpha is 0.05, and the critical value which we get from the table is plus minus 2.064, correct? And so what I say, I will be saying that the value which I am getting is, so the critical value is, what value I got from the test statistics over here. Again, go back and check, just a second. See, this is the value which I have received through my test statistics. No, through as a critical value. And this is the value I received through the test statistics, correct? One more part I wanted to make you clear over here is, see, when I say my mu is equal to 30 and when I say my mu is not equal to 30, not equal to 30, याचा meaning असा असतो की माझ्या normal curve मध्ये this value can lie at the both the sides. माझा normal distribution चा curve असा आहे. So my critical value can lie to the both the tails. So this is my two-tail test. And when I say, see, suppose माझ्याकडे greater than किंवा less than equal to असेल काही, म्हणजे mu is equal to 30 and mu is greater than 30. Greater than म्हणजे value greater than, right? So that is going to be in the normal distribution curve, which is going to be left tail test. Correct? कारण की ते एकाच साइड आहे ना, greater than. Less than will be right tail test. एकाच साइडला आहे. So when there is a greater than or less than value, it is going to be the right tail test or the left tail test. And when I have the not equal to value, it is going to be two-tail test. I hope this is clear with all of you. So over here, it is written as the two-tail test. फक्त सिंपल वर्ड्स मध्ये लक्षात ठेवा, खूप कॉम्प्लेक्सिटी मध्ये जाऊ नका. Whenever I have not equal to, it is going to be 2 tail test. And whenever there is a greater than or less than, in the alternate hypothesis, it is going to be 1 tail. Whether it is a right tail test or a left tail test, it is going to be 1 tail test. So over here, I have to look into t-test, which is the 2-tailed t-test, the table of 2-tailed t-test at the alpha value of 0.05 and the degree of freedom as 24. I get a critical value as plus minus. Value plus minus. Either it can be at the right side or it can be the left side. So that's the reason it is a plus and minus value. Correct? And so I get the value as plus minus 2.064. What is the value which I have got through my test statistics? I have got this value through my test statistics. That is my minus 2.5, correct? So at minus 2.5, I have got some value. So since the minus 2.5 is less than minus 2.064, लेस दॅन आहे ना त्याच्यापेक्षा, करेक्ट? त्याचा अर्थ काय? तो क्रिटिकल रिजन मध्ये लाई करते ही व्हॅल्यू. सो वी रिजेक्ट दी नल हायपोथेसिस. Correct. And so what is the conclusion? There is enough evidence to reject the company's claim that the average age of employees is 30 years. The sample data suggests the average age is significantly different from the 30 years. I hope this is clear with all of you. This is the first example of t-test where we have seen the concept of 2-tail, 1-tail test also. Right? We have seen the critical region value, which was there already in the chi-square test also. I hope there is no question in this numerical. So we'll move ahead. We'll see a few assumptions of, and these are the important assumptions of the t-test. Please remember, you are going to get the numerical, you are going to get the questions on the basis of these assumptions also. So the data should be normally distributed and it has to be for the small value. Please remember. Whenever I am going to work for, whenever I am going to use the t-test has to be used for the small sample size only. Small sample sizes only. Is this clear with all of you? Good. So for the sample 2 t-test, the variance of the two groups should be equal and in the sum versions of the test. And for the paired t-test, the differences between the paired observation should be normally distributed. So when is to use the t-test? When the sample size is small, that is less than 30. Sample size तेव्हा less than 30 आहे, small आहे, तेव्हाच आपल्याला t-test वापरायची आहे. I hope this is clear with all of you about the t-test. Correct? So move for the next test. Next test is going to be a Z test. Okay. Before that, again, so any question over there in the t-test?